How's it going, everybody? In this video, we're going to go ahead and take a look at our next IP routing topic, which is going to be floating static routes. Now, if you're not familiar with the concept, it's actually pretty straightforward. When you're dealing with a static route, by default, the administrative distance is always going to be 1 for any static route you can configure if you don't do any type of manipulation or anything like that. A floating static route does not have an administrative distance of 1. It has an administrative distance of 2 through 255. Now, when would you use this floating static route? And why is it called floating? Does it actually float? No, it doesn't float. The idea is that its administrative distance is set a little bit higher or less preferred than that of a regular static route, with an administrative distance of 1 being the lowest it can be, besides 0, which is connected. So connected is always going to trump static, right? Where a static route will always have a value of 1. But if you don't want that route, for whatever reason, to be installed in the routing table, you can give it a higher administrative distance. An administrative distance, anything higher than 1, will be considered to be floating. So 2 through 255. Now, one thing about the 255 particular part is if you give a floating static route a value of 255, you're basically saying never install this route in the routing table. It's kind of it's kind of weird. I've been in a couple of environments where I've seen floating static routes configured with an administrative distance of 255, and I'm like, why didn't you just know it out or remove it? And I was given some excuse like for auditing purposes or something like that. But if you configure a floating static route with an administrative distance of 2 through 254, it will be injected into the routing table, assuming there's the need for it. So when might you use one? Well, I'm glad you asked. We're going to talk about that real quick and break down the why, because we need to know that, right? It's the third letter in May. So the concept is actually very, very simple. Let's assume that on iOS 45 that our default route is pointing us towards XR21. Okay, it just happens to be the direction we're going to get to a particular destination. Maybe that's the best route in order to go to the loopback address of router 8, which, by the way, is going to have an address of 200.2.0.8, just for reference purposes. Now, if I try to go this direction, then I'm going to have to take into consideration that I'm going to be 2 hops away from this. Where if I have an alternative path this direction, right? This is going to be my second hop. This will be my third hop. Actually, let me change the color so it's a little easier to follow. Let's change this to green, light yellow green. And if I take this path this way, this will be my second hop. This will be my third hop, and this will be my fourth hop. Okay, so it's a longer path, less preferred. But from a routing perspective, do we really care about how many hops away it is? Not really, no. But from a administrative distance, we do. So how do we change the difference? Well, let's talk about that real quick. Let me scoot down just a little bit and jump out, and let's do just a touch of whiteboarding. So when we talk about the routing concept, when you deal with a regular static route, I'm going to say SR for short, you type in IP route, and you do 10.1.1.0/24. I'm just going to put a 24 in here for /24. So this is going to be the subnet or the prefix, and this is going to be the length. Okay, and then do a next hop of 10.1. Let's do 1.2.1. Okay, that's going to be our next hop. By default, you don't see it, but there's actually an implicit 1 added here. This right here is the administrative distance. The only thing that trumps this is a 0, which is then a connected route, right? And you can't beat that. Now, if I was to make this value right here, anything from 2 through 254, then this will be less preferred than the 1. So I could have another route, IP route, to 10.1.1.0/24 to 10.1.3.1 with a value of 2. I have one route here and I have a second route here. Which one gets installed? Well, this one, right? Because it's got the lower administrative distance. Now, what happens if this route goes away? Let's talk about that for a second. What happens if the connection between this router, the one we're talking about configuring the static route on, and the next hop IP? What happens if that route goes away, or that connection, maybe this interface right here, the subnet right here goes down? The interface that's tied to this subnet goes down for whatever reason. Upstream connection's broken, what have you. Interface is shut down. Doesn't really make much of a difference. What happens then? Well, the cool thing is if there's already a static route, a floating static route configured, then this guy then gets injected into the routing table. And that's the beautiful part about how this operates. So you can go through and lay this out so that it gets to where it's got to go and everybody's happy. And that's really the benefit to dealing with floating static routes. It provides you a static route backup, for lack of a better term. So when might you use one? Well, let's say, for instance, that I've got ISP1 and I have ISP2. The circuit speed is kind of irrelevant, right? But I have a router, and I have a default route going this direction, and I have a default route going this direction. Which static route gets injected by default? Well, if we're not doing any modification, both get injected. So I have a default route via ISP1, and I have a default route via ISP2. Now, can I load balance? Sure, you sure could. But the problem with that, though, is you run into traffic coming back in being the problem. So can you send traffic out? You can. The problem with that is you run the risk of traffic going out, right? Going out this direction and then potentially coming back in this way, depending on how the routing is set up. But Rob, if this is 1.2.3.4, well, 3, we'll do 0/24, and this is 4.5.6.0/24, the source IP will be coming from this guy, right? If it goes out that direction. That's true. You will be sending some of your packets, but if you have two static default routes in your routing table, you're going to send some packets out one way and some packets out the other. So you're going to be load sharing. The problem occurs when you have return traffic. You can't guarantee that traffic is going to come back in the same way. The routing on the internet you can't control. So in an ideal environment, internally, you could have more control on that, right? But in this case here, you would need additional. This really isn't a good idea to try to load balance your traffic or take advantage of both circuits. It's really not a good idea. You would more or less want to use some sort of load balancing technique. Maybe you could use BGP and then you tie that back to some sort of application layer monitoring, like I can't remember the name of the service that I've seen used, but you could, Noction. Noction is something I've seen used, and it allows you to load balance across all of your internet circuits, but I've never seen load balancing work out really well, so I tend to not steer people that direction. Instead, I leverage the ability of modifying the administrative distance on the default route. Instead of making this a 1, and that's a horrible 1 by the way, this a 1, and this a 1, I take one of these two circuits and I bump up the administrative distance. So in the event, let's say we'll take this guy here, we'll make this a 10. Even though, let's say each one of these is a 100 megabit interface or 100 megabit circuit, by modifying the value to one of those default routes to be a higher value, then we no longer have this one in the routing table. This one is pulled out of the routing table. It's configured, but since the administrative distance is higher, it's less preferred and not injected. Now, What happens if this route right here goes down? Now, the problem with this is that in order for a prefix, a default route, to be removed from the routing table, the interface that's tied to the default route needs to go down. So what if this guy right here, this interface right here, never fails, but the internet connectivity upstream of it is it fails, but the interface itself doesn't go down? What do you do then? Well, that's when you need to bring in some more ambitious techniques in order to take advantage of that, which is basically what you use enhanced object tracking in IPSLA. So the idea is, in the event that you have a scenario where the internet connection is traffic for some reason fails, the internet isn't working the way that it's supposed to, people are calling you saying, hey Rob, things are broken, I can't get to the internet, or I can't open up my Google Mail, or whatever the problem is that they're facing. And then you look at the routing table like, oh, well, the default route is still there. And then you realize that when you go to try to do a ping, that the pings fail. So every once in a while here at home, my internet doesn't work. And I have to okay, what's the problem? So I'll lose connectivity. I have some active monitoring that's pinging Google all the time just to make sure that Google's working. But if Google DNS fails, for example, right? What happens then? Well, my PCs can't get to the internet because that's what they're using as their DNS server is Google, so they can access pretty much anything. Then I have to jump on my internet edge device, and then I have to go and source traffic from it. Can I ping Google? And if I can't ping Quad 8 when I go to ping it, then that tells me that the internet upstream of my internet edge device is not operational, but the interface physically connected to my internet edge device is still up. It's still working. So how do you combat that problem? How do you switch gears between those two? There's a couple different ways that you can do it. There's an advanced way, which is taking advantage of Embedded Event Manager, or EEM, where you create an EEM applet that with a bunch of individual actions in it and says, okay, in the event that you can no longer ping Google, you're going to configure the EEM script to shut down the interface that is tied to the primary default route, and then by shutting down the interface is tied to the main default route. So by shutting down this interface, you remove this route from the routing table, which makes this guy right here get injected into the routing table. By doing that, you are now sending traffic this direction versus out towards ISP1. Traffic now goes via ISP2. Everybody's happy. Now, there are some, I've used EEM a couple of times in production because I needed something that was a little bit more robust. They configure enhanced object tracking and IPSLA with static routing. That's what they refer to as reliable static routing, when you're doing a consistent ping and things like that. Now, I'm not going to go into a ton more detail on the reliable static routing because I want to do that in a different video, and then I want to get into some policy routing and how that can get tied to it. So what I'm going to go do is I'm going to clear the screen, and we're going to go take a look at a real quick example of how this would work. What I'm basically going to do, just for the simplicity of it, is I'm going to enable EIGRP on these connections, XR21, iOS 8, iOS 6. We're going to get EIGRP running here just so we have reachability, so that when I configure two static default routes on iOS 45, we'll be able to reach it. And then we'll be able to, I'll have this interface connection, I'll advertise these links into EIGRP so we can get from iOS 45 to iOS 8. And then we'll take a look as to how static routing comes into play. So let's go ahead and pull up Secure CRT and actually walk through this demonstration. So the quick way to test this out would be to go to iOS 8, and I'm going to go to Global Config. I'm going to type in do show IP interface brief. I'm going to type in router EIGRP1, and I'm going to specify network of 200.8.0 0.0.255.255, and the same with we should be okay with just that because we don't need to come in via iOS 7. We should be fine that way. So I'm going to do that, and then I'm going to go over to XR21 and configure him to do the same thing. I'm going to log in as Cisco, go to global config, router EIGRP 1, type in address family, IPv4, autonomous system 1, and then I'm going to type in interface gig 00000, and actually let me go back to router 8, and let me type in network of 200.2.0.8, and then that, so we know it gets up and running. Then I'm going to come up here and do gig 0/3 and gig 0/2, and then I'm going to go ahead and I'm going to commit that config. So we should form an EIGRP adjacency with iOS 8 relatively quickly. And then I'm also going to go over to, there it goes, I'm going to go over to iOS 6 and do the same thing. I'm going to go to router EIGRP 1. Let me just make sure that I'm not EIGRP 100. So router EIGRP 1, I want to type in network of 12.6.21.0, 0.0.0.255, and then network of 100.6.45.0, 0.0.0.255. Now by doing all this, what I'm doing is, if I do show IP route EIGRP, I am going to be seeing I see the 821 network coming across. I see 822 coming across. I see 846. I see all the links that I need to see. Now, if I go to iOS 45, which is way over here, and I go to here and I do a show IP route, I don't have any static routes configured, right? So if I go to global config and I IP route, so let's say I just configure a default route to 200.21.45.21, and I also do one to, let's go do show IP route now, do ping 200.2.0.8, and I'm able to ping router 8's loopback. If I do hit the up arrow and I pull this one out, pull the next hop, I don't remove it, but I add one, 100.6.45.6, and do show IP route. You'll see that I have two static routes injected in the routing table. If I try to ping it, I can still ping it. Now, if I go to router 8, and let me just do a quick telnet test. Let me come in here and type in line BTY 04. Login is local, and transport input is all, and then exit out. Username is Rob, privilege level 15, password Cisco. And I come over here to iOS 45, do telnet to 200.2.0.8, login is Rob and Cisco, and then go to global config and type in no IP domain dash lookup, do show users. I'm coming from 200.21.45.45, which means I'm coming in this way. Now, some of this has to do with the fact of the way that router 45 is going to forward traffic. So if I do a show IP, let me exit out completely. If I do a show IP Ceph, and I look at the internal for all zeros, internal, oh, I meant to say, let's see, 0.0.0 internal? Is that what I'm looking for? It is. So it says right now that I am, oh, I meant to say 0/0, not. Okay, so let me go ahead and scoot this up just a little bit. So it's saying that for some reason this is incomplete. Not sure why it says that. But when we look at this, it's going to do per session load balancing. So now if I go back to that telnet again, telnet to 200.2.0.8, Rob and Cisco and do show, or sorry, show users, we can see that we're still coming from the 221.45, right? Now, in the event that that link goes down, the connection to AS200 fails for whatever reason, I have an alternative path, right? So let me go exit out of here real quick, and let me show you how this would look. If I go to iOS 45 and I go to do show IP route, I see both of them in here, right? Now if I go to do show IP interface brief, make sure that that's up, and it is. Do show run interface, do ping 100.6.45.6. Make sure it can actually ping it. That might have something to do with it. So I've got on the wrong interface, that's why. Control Shift 6. Let me go to interface gig 0/1, no IP address. Interface gig 0/2, IP address of 100.6.45.45/24. That's probably why it said incomplete, because it couldn't resolve the IP. We're going to no shut that one real quick. And we're going to do show IP route. It should still be in the route. Do show IP ceph 0.0.0.0/0 internal. There it goes. Now it's going to resolve. Now if I was to do that telnet again, Rob and Cisco, show users, I'm coming in from 221.45.45. What I'm not trying to show you is the load balancing mechanism, but if I was to go to iOS 45, and which I'm already on, if I come up here and I type in interface gig 0/0 and I say shut down, I actually have to fail the interface down, do show IP interface brief, and then do show IP route, in order for that other default route to come into play. Now if I come out of here and I ping 200.2.0.8, and then I do a telnet to 200, I should be able to telnet to it from here, and do Rob and Cisco and show users, now I show is coming from 106.45.45. Okay, that makes sense. Now, let's go back to the configuration of iOS 45 and let's give the path towards iOS 6, that particular static route, let's bump its administrative distance to be higher and see what that looks like. I'm going to go ahead and exit out. I'm going to go back to interface gig 0/0 and no shut the interface. I'm going to go now to the default route. So do show run pipe include IP route. I'm going to go underneath this one here, and I'm going to configure it with an administrative distance of anything higher. So for example, we'll say 10. Now if I do show run pipe include IP route again, now the administrative distance has been changed. Do show IP route. Now we're only going to have one static route in the routing table. Everything's looking pretty good. Now here's the kicker. If I go to XR21, for example, and I type in, we get out of EIGRP config mode and type in interface gig 0.0.0.0.2, type in shut, and then commit it, what should happen is iOS 45 should theoretically detect that failure. So do show IP interface brief. The problem is there's really no carrier sense. Not saying that there isn't, but in my experience, a lot of it is it's not there. Not like a physical interface. There's no real carrier sense going on. Because if I was to do this, do show IP route, I should not be trying to forward traffic towards iOS 8. So do ping 200.2.0.8, I'm not going to be able to get there because the upstream interface, unless the carrier sense on iOS 45 detects the link down from XR21 on gig 0/2, iOS 45 will always keep that route up. That's not a specific to physical routers. That's a specificity, or sorry, that's not that's an issue with inside of Eve and Genus 3, where the link detection, there's no actual like carrier sense. It doesn't detect that the link has been taken down. Because when you do that, what will end up happening is the back and forth electrical signals across the wire and the lights on for the fiber, they go down. Then the other side detects that down and then goes to up down, which means the interface is physically up, but the carrier sense, or the line protocol, the actual back and forth communication between the two devices, is down. So if we do show IP interface again, we're going to see that it's up, up. In order for this default route to fail over, I need to go to interface gig 0/0 and shut it down. So once it goes down, once the interface itself physically goes down, then I will be able to send the default route over towards router 6. Now, what I'm trying to simulate here is if you have an upstream failure come into play and you are getting that harassing phone call from people saying, hey, internet's down, what do we do to fix it? This is one of those times where you have to be like, well, the upstream internet connection is down, but the connection between your device and whoever it's upstream connected to is still up. So for example, you might have a router at a site that connects into a cable modem. But if that cable modem Ethernet connection from the cable modem itself to your router is still up, then the static route's never going to go away because the interface is still up. But the upstream connectivity north of it, out in the, a couple miles from your house, that might be down. And that's where you run into this problem. This is where reliable static routing comes into play, where you tie tracking to a particular default route, and in the event that that fails, the tracking removes the static route. Now we'll talk about that in the next video, which is reliable static routing. But you still have to be able to tie those details together. So I've ran into this a few times with customers where they have multiple internet circuits. You have a primary and you have a backup, and then you want to bring the backup into play. Now if I was to go back and do that ping again, the ping works, right? Because I've sent my traffic over a different direction, and we can see the administrative distance is 10. So if I go and type in no shut, and then I go to XR21, I type in no shut, and then I commit those changes, it's going to bring that back online and we'll be in good shape. We go back to iOS 45, the link will come back up, and then I'll do a show IP route. I'm going to be going back towards XR21. I do that ping, and it works as well. But this is only good if the physical link on your router goes down. If the physical link stays up, you are up the creek without a paddle, unless you have some sort of other configuration options available to you. We're going to talk about reliable static routing in the next video, but I wanted to at least go into that level of detail because it's something that I've seen a lot of people struggle with, and I've seen it fail where I've had to step in and take over some situations when they go awry. So just the more you know, right? With that being said, ladies and gentlemen, thanks so much for stopping by and hanging out with me in this video. And until next time, guys, take it easy.